Okay, so you know how the last couple of days we've been talking about protons, neutrons, and electrons, and I said for now, atoms are neutral. So that means protons and electrons are equal. That changes today. Okay, you guys have probably actually heard of these before. You've heard of what an ion is in physical science, but we've slept since then. So just to remind you, an ion is an atom or a group of atoms. Probably around Thanksgiving, we're going to learn something, polyatomic ion, which is a group of atoms that has charges. Okay, so they can be positive or negative. In order to form an ion, you have to have some sort of transfer of electrons. Sometimes they are giving electrons away. Sometimes you are stealing electrons from another atom. There can be two types of ions. The first one is called a cation. Okay, these types of ions are positively charged, which means they have to lose electrons. The second form is an anion, which are negatively charged, which means they are gaining electrons. So when it comes to test day, and I ask you, which of the following is a cation, which by the way I will, and you go, oh no, I don't remember which one's positive and which one's negative. You'll remember me saying this right now. If you look at a cation, you notice that there is a T in the word, correct?
Yeah.
T's look like plus signs, don't they?
They sure do.
Therefore, cations are positively charged. Okay, few more things about ions. Did you ever hear me say the word proton when I was describing an ion? No. What happens if you lose or gain protons? What happens to the element? It becomes a completely different element, right? So in order to form an ion, you have to gain or lose electrons, not protons. So when we are trying to determine the charge of an element, you have to look at the difference between protons and electrons. Okay? But you can never, ever lose protons or gain protons. Okay, so when we are writing ions, just like we can write isotopes, we learn how to write isotope, there is a way to write ions. So when you are writing ions, it's really easy. All you have to do is write the charge in the top right-hand quarter of your element's symbol. And again, this charge is telling you not how many electrons you have, but the difference between protons and electrons. So let's look at sodium. Sodium plus means that this sodium has a +1 charge. Okay, what that means is there is one more proton than there are electrons. To kind of try to help you visualize this, let's draw an atom really quick. Here is my nucleus. In my nucleus, sodium has 11 protons because it has an atomic number of 11. So I'm going to attempt to draw 11. 5, 6, 7, 8, 9, 10, 11. I ran out of room. So we have 11 protons in there. But it has a +1 charge, which means we have to have one less electron, which means we have 10 electrons, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when you're trying, I told you what the charge is, but in case you're trying to figure out the charge, I think to myself, this is a game. This is a game between positives and negatives. Who's winning right now? Who has more?
Positive.
The positives. There are 11 positives and there are 10 negatives. So who's winning? The protons. By how much? 1. So that means my charge is +1. The biggest mistake people make right here is when you think +1, you automatically want to think, oh, we have gained 1 electron. +1, we've gained 1 electron. But you actually have to do the opposite when we're doing ions. So the first couple times, before we get really good at this, try to get in the habit of checking yourselves. So let's do another example. Let's do one of the negative ones. Let's do oxygen. Oxygen has a charge of 2-, which means what? It has two more electrons because it is negatively charged. The only way you can become negatively charged is if you gain electrons. So let's draw another picture of it. Oxygen is the atomic number of 8. Which means it has 8 protons in the nucleus. 6, 7, 8. So there's our 8 protons. Usually oxygen has 8 electrons, right? But this time it has gained 2 additional electrons, so it's going to have 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now when you're trying to figure out the charge, you say, well, I have 8 protons. I have 10 electrons. Who's winning? By how much? So my charge is going to be 2 negative. Okay, now the correct way is to write the number and then the charge, so 2 plus, 3 plus, 2 minus, 3 minus, but I write it both ways. I don't care if you write plus 2 or minus 2. I will accept either way. It's really not a big deal to me. One more thing that I want you guys to look at is I want you to look up at the periodic table. Okay, draw like an imaginary line halfway through it. Kind of actually take aluminum and draw an imaginary line through aluminum. Down. Okay, anything to the left of that guy are going to form cations. Anything to the right of that imaginary line are going to form anions. Now, is it a perfect science? No. That's why it's an imaginary line. But for the most part, everything to the left is positive, everything to the right is negative. Not always, but most of the time. Okay? All right, so this is how you write an ion. Just like we learned how to write an isotope. How do you write an isotope? Not the symbol. We're not talking about the symbols. How do I communicate an isotope? So if I'm talking about carbon with a mass number of 12, how do I write that? How do I say that? I say what, Corey? I would say carbon 12. So when I am writing an isotope, I say carbon 12. And this is telling you we're dealing with carbon, but it has a different mass number. It has a mass number of 12. That's how you write isotopes. To write ions, you just simply go, you write the symbol, and you do the charge. So this is an ion. Okay, that's how you write ions. But now we're going to talk about symbols. Okay, so far we have learned how to write a complete symbol, right? We know that we're supposed to write the symbol of the element. We're supposed to write the mass number as a superscript on the left. We're supposed to write the atomic number as a subscript on the left. But now when we're writing complete symbols, you also need to add the charge as a superscript on the right. So we were just talking about oxygen, so let's do oxygen. We just did oxygen 2 minus, correct? So if we were to write a complete symbol for oxygen, first thing I have to write the symbol, so O, and then I need 3 scripts, correct? Where do I put my charge at? Top right. Oxygen was 2 minus. I still have 2 more to do. What else do I write? What's the mass number of oxygen? 16. What is the atomic number of oxygen? 8. So this is a complete symbol. This is not how we write an ion. This is a complete symbol. Does everybody see the difference between writing an ion and writing a complete symbol? Mm-hmm. All right, so let's do some practice. So the first one says, how many protons, electrons, and neutrons does nitrogen have if it has a charge of -3? So to do this, we have to first of all look up nitrogen up there. Nitrogen has an atomic number of what? 7, which means it has what? 7 protons. Okay. Next, we need to figure out electrons. Well, I'm telling you that it has a charge of -3. Does that mean it has 3 extra electrons or 3 less electrons? 3 extra. So if it was neutral, it would have 7, but it's not neutral. It has 3 extra. So we're going to have 10. Okay, so next we have to do neutrons. How do we do neutrons? We do mass number, which is 14, minus atomic number, which is 7. So total we're going to have 7. All right, let's do a cation now. This one says, how many protons, neutrons, and electrons does calcium have if it has a charge of +2? With a charge of +2, first of all, we have to look up calcium. Calcium has what kind of, or what's its atomic number? 20. So how many protons? Okay, in a neutral atom, it would have 20 electrons, but it's not neutral. It has a charge of +2, which means what?
18.
But what does the +2 mean? It has lost 2 electrons, which means it is 20 minus 2, which equals 18. And then lastly, we have to do neutrons. To do neutrons, we have to take the mass, which is 40, minus protons, which is 20. So, 20. Yeah. Alright, so let's practice writing some symbols now. The next one says, please write a complete symbol for an atom of bromine with a charge of -1. First of all, we have to write the symbol, which is Br. Okay, it has a charge of -1. Okay, where does the mass number go? The top, so what's the mass number of bromine? 79.9, so we'd have to round it to 80. What's the atomic number for bromine? 35. So let's just take it one step further. How many protons? How many electrons? 36. How many neutrons? 45. 35 protons because the atomic number is 35. 36 electrons because we have one more electron than protons. And 45 neutrons because we did 80 minus 35. Okay, so now let's do this one for potassium. What's the symbol for potassium? Okay. It has a charge of 1 plus, correct? So, what's the mass number for potassium? Mass number 39. What's the atomic number? So, just one step further, how many protons? There are 19 because the atomic number is 19. How many electrons? 18 because we have one less electron than protons. And how many neutrons? 20 because 39 minus 19 is 20. Alright, so we are done with notes. I'm actually going to hand you guys out 25 practice problems, which sounds like a lot, but it's really not. Writing symbols doesn't take very much time. But the only way we're really going to learn how to write all these symbols and protons, neutrons, electrons is if we get lots and lots of practice. So, but since I'm giving you a handout and not on the computer, it's very important that you don't lose it because your homework quiz is probably going to be on Monday. So don't lose this between now and then. If you are done with your lab, great. If you are not done with your lab, I would prefer you finish your calculations before you start on this. And if you haven't done the lab at all,